Alright guys, so real quick here I'm going to show you how to reverse engineer the hologram here for extra credit and to actually add a few more things to it. And I'm going to go over mainly the things that I'm going to be adding and a real quick review of the nodes and what's going on under the hood. On my particular one, what I added was a new glow and a new panner. So you can see here we have a few other things in here, which we'll go over in just a second. And I'll show you how to set them up. And then we connected it back into the hologram. Now, if you don't want to do a panner, maybe you want to do a rotator, you can. I have a little panner. If you look really good, you'll see it vibrate. And the coordinates that I have set up is basically coming from the texture coordinates node right here. I set to 300 and 300. Now, you can do it that way. It's kind of old school. Or you can just kind of grab the vertical scrolling nodes that they have set up and plug them in the back of the texture UVs. Excuse me. That's just the coffee speaking. And you can imitate what they have, but just be careful. Just make sure that you double check your nodes, and you'll see there's a panner that has all this input and then goes into the UV set. And mine pretty much has a panner with only the texture coordinates. So you could copy what they have, put it into the panner, put it into the texture coordinates. So let's actually go over what's going on in the under the hood here, under the surface. So I made a brand new material. So the first thing you need to do when you do a brand new material, you need to make sure that you set it to translucent, and you also want to make sure it's unlit. All hologram stuff need to be unlit. Here's the first nodes that we have to mess with here. This is going to be our vertical line. So I can right click on these guys. Oops, excuse me. Right click and create a comment for this. We'll call this vertical. We have to click here first. Vertical plant panning lines. And all I did was grab some of the nodes, and if you need to do this, you can. You just got to understand what's happening, though, and building it one by one can take some time, but it actually will allow you to get better at creating and controlling materials. There's a screen position. Now, the screen position data, this input data, basically takes your camera and calculates, with all these other nodes coming in, calculates where your camera is going to be in relation to your object that you have the material on. This will allow us to actually fool the camera, fool the eye, and make people think that we're looking, when we're looking at this object, that only certain angles it's going to display. Now, this is just a small bit of that. There's a lot more of this going on under the hood. Let me get rid of this particular node because we have a double in here. And again, you want to call it up. You just type in screen position right there. We have a scroll tiling. So what this does, and it's not really a scroll tiling, that's just renamed that way. At any time you want to do so, you can. You can also add a toggle comment button. So if you want to say, hey buddy, don't mess with this, don't mess with that. I just want to point a few of those things out real quick. But this is really just a scalar parameter. And to get to a scalar parameter, you type in scalar. There you go. And you call them up. And all you can do from there is you can rename him by clicking on that little node section. So this guy, let's get rid of him completely. So this guy, he's set to a default value of 60. And I think all of them should be set by default. Make sure I'm not telling you that in error. There's a lot of nodes. It's easy to get. Oh, no, his default 0. Sorry about that. So set yours to 60 on him. And this is going to be our default value overall. And what this guy's going to do is going to help with our look and feel for our lines. Now, let me show you how this plugs in. Because we have screen position parameter. By himself, he does nothing. This guy, the scalar parameter, by himself does nothing also. But what we need to do is plug them into the multiply to get them to have a relationship now. Now, the multiply is going to be used as kind of a bridge in a way. And it's going to grab both of these parameters and it's going to allow us to plug it into our panner coordinates. So we can now see that the position of the camera and the scroll tiling here of our overall scalar parameter. And the scalar, if you're ever not sure about these, you can control Alt and it'll tell you. It is an expression outputs a single float value constant that can be accessed and changed in an instant of the material or on the fly by the code. So this little guy plugged into the multiply is going to allow us to control a bit of the strength for our screen position movement and allow us to control our coordinates here for our panner. But there's more to it. We want this to move kind of with a little bit of time data. But this time data is just going to be a default set to 0. The only reason we're putting this in is so that when we make another scrolling line velocity based on our scalar deal, so if we make another scalar, that's pretty much what he is on the bottom. And these have a consistent color, so if you're not sure, you can look at the colors that you've already made, and you can kind of guess what that node is, but pretty much if you click on it, you'll get your info that you need. So this guy here is our parameter here, and he's going to be set to 1. This is called our scrolling line velocity. So again, he's like a constant. He's like a control of speed and strength that you saw me show in class. We're going to set that to a B, and the time input, we're going to set that to an A. And then we're going to go down here, and we're going to create a fractal node here, this guy. If we click on him, you'll see material expression, and you can just type in frac if you want to, which sounds like a bad word. And it allows us to go in here and plug in these variables, and again, so it actually calculates with this multiply. It'll complement this multiply to give us the output that we need. So the multiply doesn't just automatically go into another multiply. That's a little bit redundant. But this guy here, Control Alt, you can see again, it's a fract expression, takes in value and outputs the decimal part of the value, seen also as a seal or floor. So it gives us kind of a range to steal, I guess you could call it almost a bracket in a way. Keeps things in order. But it makes it a lot easier to go into our multiply. And then we have a scrolling line height. This guy, again, they're like, they work a bit like constants, which you saw Unreal define. And this one's set to 80. So again, you can make another scalar, and anytime you can do Control C, Control V. Oh, let me do Control Z for a second. Control C, I hit V on accident, and then you can do Control V to get him back into the scene, and set him to 80. And then we want to drag him down and put him into the the A channel here. This multiply, and this multiply is finally going to go into the time, which is going to then go into our texture node. And now it's going to define what that's going to look like. Basically taking care of the coordinates and now making it so that it moves over a period of time here. And then last but not least, we have a multiply. And this guy, if you're wondering, is a constant. So like I showed you in class, to call a constant up, you just type in constant. Pull them up. And this particular constant is set to 0.1. So I'm going to drag this guy down to the B channel for the texture, and the constant will set into the A. All right. And if these get flipped, it shouldn't be that big of a deal. Let me know if you do run into problems. You shouldn't in that particular case. So up above, we need to actually create a Fresnel. Now this Fresnel index, if you don't know, or Fresnel, excuse me, I always say that wrong. Fresnel indexed is used in such a way, and I should say how it's defined, is basically the rigid or change of surface, pattern, and look on an object based on a camera positioning. Your CD is an excellent example of how that works. If you get a bottom of a CD and move it around in the light, you'll see a rainbow color. That is its Fresnel index. When you pour water and it has a continuous pattern, that also too has a Fresnel index. So we need this. It's really important for a hologram to actually be believable. And you'll see us create this later on too. So we're going to create a Fresnel real quick. There we go. And we're going to create another parameter here. We're going to create another scalar parameter. There we go. And we're going to create, let's see here, a constant. And you can name these. I'm not going to really bother naming this particular guy. You can just call it Fresnel exponent or strength. And then we're going to go to our Fresnel intensity. And that Fresnel intensity, there isn't really a node for it. We're going to basically be pulling in another scalar parameter. So we'll just do Control C, Control V, and pull him down. Now he's going to be set to 8 on his default on the bottom. And the guy on the top, this dude here, is going to be set to a value of 7. And you can play with these values if you want to. And let's give him a name. This will be Fresnel, we'll call him exponent. And then the bottom, we'll call him Fresnel intensity. For now, sorry. My college professors are turning over in their grave. How dare you say that, Sean? And then we do multiply. Multiply. Oh, yeah. Trying to make it interesting. Oh, got to be able to type because that's kind of important. There we go. So we're going to connect all these guys. So let's get this guy into place. And again, you'll check on your Fresnel. He's going to be set by default to a 5.0 and a 0.04. That's fine because as soon as we plug these in, they're going to gray those out and it's going to be using our input. So we're going to put this guy into the Fresnel exponent into the exponent, F, as it says. We're going to grab our constant, and you'll notice he's at 0. That's fine. We can leave that at 0, but we can play with that later on if we want to. We just need to have another input in here. So let's put him in there. And then we're going to finally go into our multiply. And then I'm going to get to our Fresnel intensity and plug it into there. Boom! So he's eventually going to be pulled all the way down into an add and go into our emissive. We'll do that later. So we got these two guys set up, which seem kind of complex, but there's a bit more that we need to do. So we got our vertical scrolling lines set up, but we need some more input to control our lines and to have a few more things in place. So what I'm going to do a little bit of cheating here, and I'm going to explain how these guys are all matched up because it's really important to understand it. And I'm going to grab my existing one that I've already made. Not that you should do this, but I'm going to break the links too, so don't get too excited. I'm going to move these down. So I'm going to break links on all these guys. Oh no, it looks like chaos. It's not. So what I'm going to do is show you a bit of what we're doing here. So we have the jitter here. And again, this guy's just we're going to start over here all the way to the left. And if you want to tackle it this way, you can, but you need to know what's going on under the hood. I don't want you guys just copying and pasting in and expecting it to be fall into place. I'm going to ask you questions in class, and if you can't answer them, then I'll know that you were just copying what was existing, what I gave you. All right, so we're going to go over here. A few things we need. We need another time node. We made that earlier. We need another scalar node. We set that to 8. And we're going to need a multiply. Now these guys are going to be the base of adding more, I guess you could say, a little bit more movement. It's going to be plugged into the opacity as well as going to be connected to an add. It goes into our emissive. But what these guys do are just going to make it look a little bit more robust as a hologram. Now there's another thing in here called a sign. Now Control Alt, if you ever want to find out what these are, it says a sign expression. Outputs a sign of the value input in radians. Most commonly, this is used to output continuous or oscillating waveforms. I'm just going to leave it at that. So basically oscillating, it's going to help us get some movement into this hologram. All right, so let's go and plug these in first before we go into buttonology and you get completely confused. So we're going to plug in our time into the A, the multiply, and our jitter velocity, which is set to 8, we're going to plug them into the B. And from there, we're going to go into our sign, which is going to help translate this information with our time output and our jitter velocity, which is kind of like a constant. It's going to allow us to actually plug this into another multiply. Now this multiply is going to give us some strength here because we'll also have our jitter size. Again, he is just another scalar parameter, but he's this time set to 0.02. And we're going to punch him right into here. And I'm going to grab our sign and drag him across here to our A multiply. All right? Cool. And again, this is using several different hologram tutorials I found on the internet, and I wanted you to understand how these work, and I wanted to build these so that you understand under the hood what exactly is going on. So above us here, we have hollow tiling. What is this again? Don't let that confuse you because it's renamed. That's another scalar parameter. But this one's set to 180, so he's a bit stronger. And he's going to be doing the same thing we did down below. And we're going to get that guy and plug him into the A of the multiply. And then the screen position input data. Now you'll notice there isn't anything here. It's using screen information. If we do Control Alt, you'll see it says screen position expression outputs the screen space position of the pixels currently being rendered. This will help us with a visual representation of the hologram and will later on allow us to prevent us being able to see through the item and see the back end, which is a problem with a lot of 3D holograms in video games. That's just the tech artist not spending enough time with it. All right, so all these guys are all kind of set up here. We got bridges to start getting our visual representation for this, and we want to get these guys and put them into the add. There we go. And then finally, we want to grab this add and put it into our UVs. This is going to give us our banding. Look at that. And that's all because we're using our screen position, our scalar parameter strength, our multiplies helping out, the jitter in here, and the time as well as the jitter velocity. All these guys are just, these little scalars are acting as input power nodes, kind of like constants on steroids. And they're kind of being punched into these multiplies. And then our sines allowing us to get more of that undulate or oscillating or dividing this up a little bit and getting it so we get that unique pattern. So now we're going to go into our clamp. So this clamp, let me go ahead and pull this over here. We're going to go straight into our input for the clamp. Now the way the clamp works is an expression taken in values and constants and constraints, them to a specified range. So we're actually trying to clamp this out so we just want a particular range on here. We don't necessarily want this whole effect everywhere. Now, we're just using it as our own means right here, in which we're plugging in the absolute value, which is reading what we have back here. We're not using the minimum and the max. You can experiment with that if you want, but we decided to grab exactly what we have and put it into here. So it's reading it, and you'll notice it automatically fills my minimum and fills my maximum, which is pretty cool. Now, if you go to a clamp, base clamp, just regular clamp, you just make one. Making a clamp. You'll notice that the numbers are different. So you can see it actually is reading what we're plugging in. I just want to make that point real quick. All right. So we got the clamp. Yay, team. And my own cheerleader. And we're now going to grab the red channel here and plug it into our minus X. Now the minus X acts as a value that we can control, and we can basically, it takes an input value and outputs 1 minus from that value. So we're actually kind of dampening the effect, the oscillating effect, and all the other nodes and scalar parameters coming in. We're kind of dampening it just a little bit. And this one's kind of important because, I mean, you can try breaking it and not having it there, but you'll notice it can maybe lessen the effect a little bit, maybe dim it down a bit. All right, so we got that there. Let's go and look at what else we have to plug in. So we have an add. So let's go and grab our clamp and punch it right into, make sure I'm on it, into the B channel for our add. And then our add's going to go into another clamp using that absolute value. Our minus, he's not going anywhere just yet. Let's finish up top here. And then here we have a constant 3 vector. Now to pull these guys up, you just type in constant. And then you can see 3 vector down below. It's set to blue. You can set this to any color you want your hologram to be. And he's going to be plugged into the multiply. So you have to make another multiply. And then that clamp's going to go into the B channel of that multiply. So we got the A, we got our new 3 constant vector into our A, and our clamp minimum into our B. Pretty cool. Not done yet down here. We're going to continue this in just a second. But let's finish it up in this area. So here's a constant. Again, these guys are used as like switches. But they're also like, I guess you could say a switch and a dial. You can turn it on, but you can also turn it up and crank it up. This guy's just set to 2. And we're going to plug this guy into our multiply B. Because right now what we're doing is we're bridging the gap between our vertical panning and our little oscillating movement. So I just move this guy to here. And then I'm going to grab this multiply, plug them into this add. I'm going to grab this multiply where we just built these two nodes and plug them into the B. Hopefully this is helping you guys out, because this is really stinking fascinating as far as I'm concerned. I love the materials in Unreal. They're so much fun. So now that we have that, we have a multiply here. We're going to actually pull this down to the A, multiply, and this is our emissive intensity. He is only set to 2, and again, he is a scalar parameter. So again, don't let these name changes fool you. He's just a scalar, which is kind of like a more powerful constant. And then now we're going to grab our add and put him into the B channel. Pretty cool. All right. Not done, because up here we have a 2D parameter texture. Now this one is the one that I gave you guys. Basically, it's just a gradient object, 2D object. It has a gradient going two different areas. And what we're going to do here is we're going to pull this in to our multiply node. Bam, right there. All right. So let me double check my notes and make sure we got everything. I'm not leaving anything out in this particular area. So you'll notice, if you look really good, you'll notice one of our adds does not have a slot. That is where our vertical panning lines are going to come in. So we're going to pull him down and punch it right into that A. Sweet. So let's go ahead and go to the bottom, because we're not quite there yet, because we have to fix some of our custom depth sorting. But towards the bottom here with these guys, I'm going to get my 1-, plug it into this clamp. Bam. And my minimum opacity. Now again, you're wondering, what are these, Sean? Again, this is a scalar parameter, so don't let these fool you. Scalar parameter. Notice the consistent color of these nodes. So if you're not sure, you can look it up that way. This one is set to 0.7. This one is set to 0.9. And then we're going to move these up into the clamp. Now what we're doing is we're complementing. Right here we have our oscillating pattern here. We have our nodes getting that to work correctly. We have a clamp, so we're in control of exactly how strong that's going to be based on our inputs using the absolute input. So we created a couple more scalars here to move into the minimum and maximum, because down here this is only taking the red channel, so we don't have a whole lot of information. So we're going to have to feed this extra information in here into this clamp. And that clamp eventually is going to go into a multiply. So we'll make a really quick multiply here. My voice almost went into puberty mode. Multiply. I wasn't scared, I swear. But this multiply is going to need some friends. He's going to need some buddies. Let's also make an add up here, which you're going to eventually need. He's going to allow us to combine some of the stuff we have up here. So we're going to get stuff in the middle we'll put into the B channel. And the A channel is going to have our Fresnel index that we created up here. And let me comment that. So anytime you want to comment them, highlight it, and then just right click, create a comment, and this is our Fresnel index here. All right, so we're almost there. Now the problem, if we apply this as it is, we're going to run into problems where we're going to kind of see through the object. We don't want that. So there's got to be a depth sorting deal that we have to deal with. So let's go ahead and make that real quick. So one of the things we're going to make, and I'll try to speed this up a little bit, is we're going to need to make a screen texture kind of a depth. And what that means is we're going to make a texture that it looks on our screen. It looks at our texture at a certain custom depth here. Let me kind of pull it up. I always get the verbiage wrong. There we go. Sample screen depth. Boop, boop. So this is one we could use, and I use this. I was experimenting with this, And you can actually get some cool stuff. Unfortunately, we're going to put him off to the side for a second. We want to do a screen texture. So let's do screen texture. There we go, towards the bottom. There we go. That's what we want. And again, this is going to act as a mask, and to help out, well, it's not going to be a real mask, but he's going to have an area where we can punch in a mask so that we're only looking at the object from the front and we're not actually looking through it. This is actually going to help. But we're going to need conditions for this. Now, this guy's a bit different. This guy gives you a lot more control in depth as a pixel offset. But, and again, I want to encourage you, you can play with this if you want to, but be aware of your notes down below, because if it doesn't work, it's going to tell you that that logic is broken. I'm going to delete that for a second. Let's go and make a mask. We're going to need a mask too. And the mask we're going to need is our component mask. And you can set it to whatever you want it to be. Right now, we'll set ours to R only, which is red. We need a depth bias. Let me move these down so we don't get confused here. Let's do a depth bias. There's a depth fade. There's multiple depths to work with. And in this particular case, actually, no, see, we don't need a depth fade. We could do that. That actually might be kind of cool. I think what we're going to build next, let's do it just the scalar. Let's keep it simple. Scalar parameter. There we go. And we'll just call this guy our depth. Depth bias. From there, we're going to go and create a pixel depth. This is an input data. So let's go and create an input data. See, we don't want to plot functional graph though. Let's just pull in data. Always mess these up sometimes. Input, my friend. I'm just going to copy what I have. Grab this guy here real quick. We just need that input node to show up. And you'll notice we have an input node here. So if that does ever give you a hard time, just type in your input and we should be able to pull them up from the very top here. Or we could even type in, let's type in our data. That was really weird that I wasn't able to pull them up. Oh well, I suck at typing, so we'll leave that input data there. The next thing we'll need to do is create, and this input data is just going to give us some more values for our ad that we're going to create, because we have to have some input values here. I'm going to pull them into the A, and then we'll get our depth bias going into the B. And then here, we're going to get our color, screen texture color here, straight into the mask, only pulling in the red channel. Now, this is all good. It can be a little bit confusing. You're like, well, I still don't understand, Sean. Why do we need pixel depth? Why do we have a scalar parameter here? And what's that set to? So our scalar parameter, we're going to set this guy to a -2. And with this -2, we're putting into the ad, but we want to be able to use this screen color here under certain conditions. We don't want it to always have the same effect. We want it so that when you get closer, you have a certain angle, you have a certain reaction. So what we need to do is make an if statement. This is connected to our math here. So this if statement is going to have a mask plugged into the B channel. We have our add here. He's going to be plugged into the A channel. This is our pixel depth and our depth bias. This is basically just an input node. There's nothing really there. Again, we need to have him there. That's why I didn't get into too much in depth with this guy. We need to have him into our add, or we could be getting an error. And whenever you're not sure about something, Control Alt, pixel depth expression outputs the depth or distance from the camera of the pixel currently being rendered. I couldn't figure out why. Let me see. Oh, that's why I didn't. Depth is the right one. I was thinking regular output. There we go. I just can't type, and I'm doing too many things and trying to make sure this isn't too long. My bad. So we got a pixel depth. So this guy's a pixel depth. If you can't find him, just type in pixel depth. I thought he was a regular input node, but that's older versions of Unreal, and this guy is a newer one. All right, so we got this set here. We also want to have some constants. We have a greater than, and if you look at this, we have a greater than equal to B, and we have an A equal to B, these two guys, and we also have a less than B. So we need constants for these, and these constants, again, are going to be our switches. We'll make another one. Control C, Control V. And I apologize for going a little bit fast there. I was having a little trouble with that pixel depth. For some reason, I thought I had a regular, just an input blank node, and it is a pixel depth node because it does have its information buried in. I should have known better. Otherwise, our add would have just not really reacted to our camera. This guy is our key one, so there wouldn't be an empty node. There would actually be a functional node there. So I'm going to go and pull this guy into the A and B, and I'm going to pull this guy into the A less than B. And I'm going to change his node parameters here. This guy can be 0, but you can increase him if you want. So if A is ever greater than or equal to B, this guy is A less than B. This guy's going to be real important because he needs to be at least 1. So whenever the screen texture color position with the mask set to B is whenever that guy, and it's based on our pixel depth information, there's A, whenever these A is greater than or equal to B, you're going to get that particular output. And down here we have A is less than B. We have a constant of 1. So this is all using our scalar information, our pixel depth information, and our screen texture information so that it masks, it doesn't show the back end of our model. There's B. So if we're far away, we're going to keep a constant screen projection control. This one's a little hard. It took me a while to, as you can tell, it took me a while to try to figure this one out. But basically, it's a conditional based on the position of our camera, and so it sorts the object accordingly. Now we have to link this to our multiply, which is going to go into our opacity. So we have a clamp, there's our multiply. Let's pull that down. And then we're going to pull this up into the B channel. Let's pull this guy down a little bit, in the middle, I guess. And then we're going to grab this multiply and pull it up into the opacity. Now you'll notice it says screen texture expression cannot use post-process input or screen color in a non-post-process domain material. So what that means, let's go back and trace that, is I need to actually double check my links real quick here. I think I'm leaving out my clamp. Let me do Control Z here real quick. There's my clamp. Let's double check to make sure my clamp is going where it's supposed to. So we got all of our nodes set up here, and then it goes into our multiply and screen position. We have multiply screen position. There we go. Goes up into this section here, which is going to complement our emissive pass here. So let me go back to the depth one. I'm going to double check too to make sure my depth doesn't have anything funky. We have the negative, we have the mask, we have the constants, we have an if statement. Our if statement goes up into our multiply. It has the clamp, which has a -7 and a 0.9. That seems to look good. And then finally, let's go and add these guys real quick here. So this multiply, we'll get back to that opacity. This multiply goes into the B channel. And then we're going to go to a multiply up at the top for my Fresnel. And we're going to add that to our add here on this guy. And then we're going to take him into the emissive color. Let me make sure I'm not missing any extra nodes real quick. Double check my notes. I think that should work. And then we punch that right into the emissive. You can see there's the lines banding. Pretty cool. And I set it mine kind of high, so it actually is pretty frequent. So what we need to do now is see if we can get the opacity to work this time. Looks like it keeps getting an error, and hopefully this isn't connected to his script. So, because I've duplicated this several times, and it should be fine. And my script's loaded, and if you open up the scene, you should also have your script loaded. So let me double check this real quick. I'm going to pause it real fast, and I'll let you know what's going on. Alright, I figured out what could be the problem here. My screen texture color, I forgot to mention, needs to be set to custom depth. Otherwise, it's going to be kind of pointless to not have that. So we got to set this to custom depth. Let me see if we can find this guy. Screen depth, custom depth here. Kind of in the middle by material, looks like it. There we go. So we got custom depth, and then now we should be able to link this up to opacity, and the logic should read. Sweet, it's working great. All right, so we got it all set up, all built and ready to go. What we need to do now is let's add some more cool stuff, kind of like what I created, and we can add a back glow and a little bit more orange going on, any color that you want for the back glow. But I figure holograms should glow. You know, the one that I gave you doesn't really glow. So let's actually talk about what I have set up here. Let me do Control C. And I'll do Control V here. So you can see what I have. And we can also see where I put it. So what I created was a linear interpret node, allowed me to bridge the if statement, the if statement of the last one, and then bring it into the emissive color, and then I brought in my extra nodes that I created. What are those nodes, you ask? Well, let's talk about those for a second. This is the location and gradient ones you heard me briefly mention before. This one's a little bit not as robust as the depth one you saw me pull up, but this location one kind of works a bit of the same. And let me show you how that works. So what I created first up was a texture coordinate. Then I created the panner. You saw me do the panner before. I set my panner speed to 30. And then I have my texture sample, which was basically the one that I gave you. It's like a little gradient. And then I also created this little sucker here called a constant 3 vertex. And again, you saw me do this before. Constant 3. Click on him. He comes up. Then I set his color to like an orange. You can do any color you want, even more blue if you want to. And then I created a Fresnel index. I can never spell this correctly. And when I pulled up the FRE, and I pulled up the Fresnel index, I made sure that I had a few inputs coming in here. So one of them being my texture and my panner, and I brought them into that exponent depth. I created a location position here, and I put it into the based refraction here. And what you can do if you're not sure if you want to experiment, you can always drag these out, pull up to here, and this will give you everything that can possibly be punched into that node. So if you want to experiment and you find something cool, make sure you write it down because you will forget. So I was playing with this and I got the local position, and this actually works pretty well. And then I also have a gradient map here. Now this one is just an option. I didn't really use this. I didn't pull in a texture to be able to connect the RGB to. And I don't have an AO. But I wanted to show you that this is an option if you want to play with this a bit more. And anytime you want to experiment, you can drag, and it'll give you the possible options to be placed within that particular area. So this guy really isn't necessary for what I was doing. But I did keep my location position, and I bridged this guy in here on purpose so that maybe if you wanted to play with it and think it through, again, you can just type in location position or local position right there. Top one should be fine. And then gradient map, all I typed in was a gradient. And, or I shouldn't say gradient. Yeah, it's gradient. I need glasses. And then just type in map here. No, it says gradient multi-map. And that's pretty much what this guy is. So you won't see exactly map. I keep saying map, but it's gradient multi-map. Allows you to put a couple of things combined in here for gradient texture. And if you want more effects going on, you can play with plugging in your own gradient textures in here. Now we got our Fresnel index. Now what I did going out of the Fresnel index, I put a base. I created that base. I set it to just 1 on a power of 1. If you go any higher, it gets too bloomy, too strong. I got my orange color, and then I got my multiply. So how do we bring these all together? So what I did is I went in here and I created a linear interpret node on mine. Let's go to mine real quick. I created a linear interpret node, and I pulled down my if statement and I plugged it into the A. And then I grabbed my multiply on the end of my power node and I put it into the B. So let's do that real quick. So let's go ahead and create a LARP. Sorry this is long. It's the only way around that. There's the only way you can do it. I'm going to put that into the A. I'm going to grab my multiply that I created, drag this all the way up. And again, the linear interpret node, acts like a bridge for these guys. And then we're finally going to put that right into the emissive channel right there. There you go. So once we hit apply, you've now made the material, and you will now have the effect. Oops, let's go back. Now you'll now have the effect of the hologram that you want. So let's too many windows open. There you go. So if we play from here, you'll be able to see the blooming effect, a little more glow. You can see the banding effect that's going on there. Now yours doesn't have to be so strong. You can play with it a little bit if you want to. That's up to you. Here's the old one. It's got my sped up panner bars going through him, and these are a little bit faster too, but it can give you that kind of that hologram effect where it looks like something's being projected. Although she's getting a little bit of the depth problem here. I mean, it's not perfect. You're still going to get some depth issues, and you can see his is starting to get a little weird compared to the old one. And part of that is that we can play with some of the parameters with that and mess with that. Let me hit escape. So that linear interpret node's grabbing our glow block here. But if you want, you can always play with the strength or the minimum and maximum with our depth if you want to. So let me make sure my depth sorting's in here. There it is. Here's my if statement down below. Let me make sure my if statement's going in there. Oh, no, we just got our Fresnel, right? So we're going to need our if statement. There he is. So we need him. Let's try and punch him into our E channel. We can play with this real quick. So I paused it for a second and figured out what was wrong with that guy. I moved my if statement into the wrong position. So I actually relocated him. He was on the bottom. I moved him up to the top. So it looks similar to what you guys had when I hand it off to you. But you'll notice here, if we look at what I have in my one that I built, we have our if statement go into the linear interpret and then go directly into the emissive. But you'll notice all of these guys go into the rest of my A and B. So you'll see this add, which has the middle section, goes into my grayed out A equals B and a greater than B. So let's double check that. So let's grab this. A equals B and then greater than B. And this should prevent our camera passing through. Now, that A channel does not need to have this guy. It actually needs to have this guy. So let's go and grab this and grab that A channel right there. You'll notice the add now goes up here. That way we're filling up all of our if statements. Sorry about that. That's just a positioning thing. I moved them up here so it makes a little more sense according to my notes. And I just grabbed the middle section of that add and stuck it in the rest of these two channels. So with that plugged into the linear interpret node, let's double check my notes here. Our opacity needs to get straight from the clamp here on this guy. So we got our jitter, we got our clamp, minimum and maximum, which we did before, and it goes straight into our color. So let's just grab our clamp and go straight into our opacity this time. So we don't need to do a combo in this guy. Let's go straight into the opacity. I'm going to break the emissive here real quick. We lose our color. You can see our banding though, or transparency. And we have a multiply here, and this guy might just be a little bit too extra for us because we don't need him really. We just have our LARP, and we have our if, and we have an add. So let's get rid of him real quick. So we're pulling our new background color into this linear interpret node. We're grabbing all the nodes that are connecting with our vertical planes, bringing them to the final output of this add, and then pulling those last two guys into the A equals B and A greater than B slots. And finally, our LARP should go into our emissive color, and we should be able to hit apply from there. Just want to make sure I corrected that. Now, if your hologram's still giving you some trouble, feel free to play with it a bit more. You can see this guy, you can kind of see the internal parts. Do kind of want to avoid that, but I think that's because I added some new things. You'll notice the old one doesn't quite have that as much. So play with it and let me know if you have any questions. And it really just is an experiment for you guys to learn and understand the materials a little bit better. Sorry it's a bit long, but I want to make sure I covered all that.